Okay, here we go. All right, let's do this. Hello, everybody. Hello. All right, hello, everybody. Hello. How's it going, everybody, here today? This up here, too. All right. How's everybody today? How's everyone doing today here? Hopefully, everybody's doing okay. Hope you all had a good weekend. Right. Thing of water. Be helpful. All right. Get a few people in and we'll get started just as usual. So, shouldn't be any problem. Thank you, Yvonne. Really appreciate that. All right. All right. So far, so good. So far, so good. A little hungry this morning. Some breakfast. All right. Good stuff. Good stuff. All right. I'm going to get started here in about a minute or two. Just wait for a couple more people to come on in, and we'll go ahead and get started. Easy peasy. Lemon squeeze. All right. We'll switch over to the. Actually, no, I could probably keep it on this. Actually, go. Here we are. That's exactly what I'm looking for. Just like so. Excelente. All right. Okay. Wait, just a slight bit more time. Okay, I think that's fine. All right. Okay. I think we got a few people in here. Let's go ahead and get going with this. All right. Okay, let's get started today. Welcome back to Tuesday. Hey, Rob, how are you doing? You doing pretty well, my friend? How are things overseas, my dude? It's always good to hear from you, my man. You're good people, Rob. Um, welcome back to Tuesday, though. Today is the only time we're going to be meeting this week due to Thanksgiving holiday. All right, so due to Thanksgiving break, Thanksgiving holiday, we are going to be meeting just this one time this week, but we do have a lot to do. We do have a lot to do to kind of catch up. Hey, totally understand, man. Shari's a good dude when he's not leaving his mic open. During Among Us, anyway. Um, okay. So, um, so today, what we're going to be focusing on here is we're going to focus on the last part of Chapter 6. Okay, Chapter 6 is going to be the latter part of what we're going to be talking about here today. Now, of course, just want to let you know here that Chapter 6 is going to be what we'll finish off here for today, and then we're going to move on to Chapter 9 after that. Okay, so that's really what it's all about. All right, so we have chapter 6 finish off today. We'll talk about a test here for chapter 6 as well once we're done with that. And then we'll talk about chapter 9 here next week once we come back from break. All right, so that's the plan here so far. There's not many sections in chapter 9, so we should be able to finish rather comfortably. Um, uh, Also, just as a friendly reminder to all of you here as well, I have updated all of your grades up to the chapter 4 and 5 test. All right, so please go ahead and check those out. All right, for your grades for the chapters 4 and 5 test. All right, so be sure that you can view those on D2L. All right. Okay, so let's go ahead and get started here. Before we do, actually, I guess I should ask: are there any questions? Any questions at all? Again, type no in the chat if you have no questions. Um, Otherwise, if you do have, if type no if you don't have any questions, or type your question out, and then you type no, I'll move on. And, we'll get going. All right. Okay, so let's talk about percentages a little bit more here today. Okay, so percentages here, we talked about the main part here last time. We discussed how to do the proportion regarding percentages. And that was the first method. And so here for today, we're going to hopefully finish off how to do the decimal portion for percentages, as we took a look at a few of those examples, but we didn't really expand upon that too much. So that's really the key goal here for today, is talking about that. Now, to remind you about what we did last week here one more time, we looked at the proportion, but today we're looking at, again, the decimal version here. So let's at least put that down. So today is this is the method for percentage for decimal percentage setup. Okay, so that's what we're going to be focusing on here today. So just to let you know, get you properly set up and ready to go. Now, as you can see here, it says part is equal to percent times the whole. Now, it says here, more importantly, we want to write the percent as a decimal before using this equation. Okay, so again, we're going to recall this probably time and time again. Part is equal to percent times the whole. But more importantly, want the percentage as a decimal. Now, let's recall also what we discussed here last week. Is we discussed some very important math language here. So give yourself a reminder here. Two of the big keys here in this case. So talk about key number 1. Remember that of means to multiply. And then, of course, key number 2 here, of course, means equals. Okay, so, all right, and then we just need to find out, again, what our missing portion is going to be, and then we solve for that using our simple algebra stuffs. Okay, let's look at the first one here. And let's see, again, let's just get comfortable with this idea, and then we're going to start just ramping up the difficulty here just a little bit. All right, so here we got 15% of 160. All right, so first and foremost here, let's break this down. All right, so we have 15% here. Okay, now remember how it works if we want to convert percentages into decimals. Well, then 15% here, remember how it works to take 15%. Remember, we moved the decimal place over to the left by 2 places, so we can move 1 and 2. In reality, 15% as a decimal is going to be 0.15. Okay. Then I'm going to write that down right here. So it says find 15%, 0.15. Next is the word of. If I see the word of means, of course, to multiply. So we're going to multiply right here. Again, just talking about our first key, just like so. And then finally, we have 160. So you can, again, bit by boop in the calculator there. That's perfectly fine. And let's go ahead and do that right now. So what is that off the top of my head? Oh yeah, Okay, that's 24. Okay. So, 15% of 160 is $24. All right, and that's how we acquire that final result there. Okay, let's start ramping it up just a tad. All right, so again, now that you have a basis about how to work with this, now we want to go ahead and, of course, use it in other examples. So let's go ahead and give this a try here. Let's give letter C a try here. So let's go over this together here. Okay. So let's look at find 0.4% of 250 patients. Okay. So what's 0.4 here as a decimal? What is 0.4 as a decimal? You can fill in the rest. This is not too hard. Of means to multiply here, and 250 is exactly 250. But really the key here is that 0.04. Whoa, be careful. Be careful about that. You're gonna fall for the trap. It's a trap question. That is a trap answer. Remember, you have to move the decimal place over 2 places to the left to get the decimal equivalent. So, Yvonne, your answer did not move it 2 places to the left. You only moved it 1 place to the left. So what would 0.4% be if that was the case? There you go. That's right. 0.004. Good. So that's the part that we need to be a little bit extra careful about. Is we get 0.004, multiply that by 250, and now we are finally going to get our answer. So let's go ahead and enter that into the calculator there. Let's see what we get. So what do we get here? 0.004 times 250. What's our final answer? It's going to be 1. That's correct. All the things, you're like, 1? You're like, yes, it is 1. All right, good. Okay. All right. All right, next. Here's another good tip here. The percent must always be changed to a decimal before multiplying here. Don't forget that. This must always be changed to a percent. From percent to a decimal. Okay. All right. Let's have you give one of these a try here really quick. Yes. This right here. Let's look at number 4. 135% of 1080. Okay. Now, before we do this out here, let's go ahead and interpret here. Of course, the toughest part is the 135%. So what's 135% as a decimal here? What's 135% as a decimal? What will that come out to be? That's right, Yvonne. That's absolutely right. 1.35. Now you got the idea. Good. Remember, 135%, you just move this over 1, 2 to the left. So same process, okay? And yeah, we're going to get a number above 1, but that's fine. We've been dealing with percentages that have been above 100% here in this chapter already. All right, let's multiply these two things straight up. So 1.35 times 1080. And what do we get here in this case? All right, cool. All right, easy peasy lemon squeezy. All right, good stuff. So again, just remember, of means multiply and is means equal. All right. In any case, let's go ahead and use these techniques here on slightly longer word problems. But now that we have all the setup here, let's go ahead and put it together here. Okay. All right. So let's say, don't worry about solving for the whole, the part, whatever you want to call it here. What we're going to look at here specifically instead is we're just going to look at the language and where we need to kind of place our numbers. That's really kind of the key here behind all these word problems is really let's boil it down into something easier. So the key here is just to put the numbers in the places they need to be based on our math language. Okay. All right. So let me show you how this works here, at least for this example. 8 tables is 4% of what number of tables? Well, let's just follow our math language here. Is located right here, and of is located right there. What number is located right here? So what number of tables? So all I'm going to do is bring the 8 down. I bring the is, which is equals. I bring the 4%. 4% is going to be 0.04 because we convert that into a decimal. We always convert to decimal, so it's going to be 0.04. Of means times. And of what number of tables? Again, what number of tables? It doesn't really matter if this is what number of whatever. It has very little relevance here. Instead, that's our missing variable x. Okay, so 8 is equal to 0.04 times x is what we get here after just setting up this problem here one piece at a time. Okay. All right, or I could just write it like that. Again, just kind of boiling it down a bit better. Okay, can anybody tell me here, how would I solve for x here? How can I solve for x? Because again, that's using our little algebra stuff. Again, we're not doing something too grandiose here. Something rather straightforward. But how should I solve for x here once again? Divide what? People tell me divide, but yeah, tell me by what? And where? Divide by 0.04? Okay. So again, 0.004 on both sides. Okay. So I need to divide by 0.04 here. And I need to do it on both sides. Yeah, remember one thing about algebra here is that you're going to be a little bit specific about where you're dividing and why. So again, we want to keep everything in balance, so make sure that you guys understand that. That's why I make you say both sides. All right, now we can plug that in the calculator there. We do 8 divided by 0.04. And can anybody tell me what we get here? It's 8 divided by 0.04. 200? All right. Spot on. Sounds like a plan, man. Okay, good. Good, good, good. Okay, nice job. Okay, let's look at another problem here now. How is 4% 0.04? 4%, Yvonne, just like I talked about before. You got to keep in mind here. Okay, go back for just a second. So keep this note in your head here. You got to move the decimal place over 2 places to the left to get the decimal equivalent for every single thing. How is 4 again? Where's the decimal point here when it comes to 4 here? So let's look at that real quick. So 4 here, if I took 4%, you have to imagine that the decimal place is right next to the 4. Then you have to move it over 2 times, which is correct. You move it 1, 2. So the decimal place is over here. So in fact, you get 0.04%. There we go. All right, cool. Okay. Let's have you guys try letter C here. Okay, so 8.5% of what number is 102? Now, to make things a little bit easier, I know that obviously with a mixed number here, it looks a little bit harder. In all honesty, I think a half a percent again is just 0.5. So a half, again, as you know here, the decimal equivalent is 0.5. So in effect, as you know, 8.5 is equal to 8.5. So another way to just describe this here really quick is just saying, all right, 8.5%. Just start with that. 8.5% of what number is 102? Bring that down there. Okay, so all right, let's have you guys figure out what number 8.5% of what number is 102. All right, so let's take a minute or so. Let's give that a try, and then I want you to post your answers there in the chat once you have them. All right, let's go ahead and give it a go. Okay, Yvonne got 12. All right. Give another 12. Okay, Ola got 12. Good. All right, we'll wait another 15, 20 seconds. Again, put your answers in the chat once you got it. Gotta imagine a microwave kind of going off at the same time. All right. Okay, let's take a look at our problem here. So 8.5% or 8.5% can be rewritten as 0.00, oops, not 0.00, what am I doing? 0.085, I want to write. I'm thinking 0.85% off the top of my head, mixing up the two. All right, so 0.085 of what number? So that's x, so times x, again, of times x, equals is 102. So again, writing this a little bit nicer here because that box is in the way. So 0.085x equals 102. Go ahead and divide by 0.085 on both sides. All right. Okay, so I'm going to stop there for just a second. This is what we have here so far. So what you guys did is, for Yvonne and Ola, you guys took 8.5% of 102 to get 12. My answer here in this case is not going to be 12. I'm not multiplying this by 12. Notice I'm taking 102 divided by 0.085. I'm going to get a significantly larger number than that of 102. Okay, so this is the part where you have to be really careful. You guys took, again, 8.5% of 102, but you have to interpret each part of the problem here down the line. So if you do this properly here, I'm going to look at another example here for sure, but do this properly here, we do 102, divide that by 0.085. In actuality, your answer is not 12, but it is actually going to be, it does contain 12, but it's going to be 1200. Will be your final answer for this problem. Again, wording means everything in these problems, so you have to look at it piece by piece. You can't make the assumption. So let's put a note here because this isn't a, this is like a, you can't make the assumption that you are taking the percentage of a number written already in the problem. That's the one part people have issues with, in my opinion, is you make the assumption I'm going to take 8.5% of 102 because those are the two numbers that I look at. When in reality, you need to be looking at the actual words and then putting those pieces together. Okay? So it's the, again, that's probably the biggest mistake that I see quite often is you make an assumption and then, well, things you don't want to have happen, they happen. So this is a good lesson to learn in this case. All right. Well, let's see if we can make up for that. Let's see if we can make up for that, and that's fine. I'm not going to get perfection, but I'm just trying to smooth out those mistakes. So let's go to, let's guys have you try one more here. All right. Let's try letter C here. So 666 inoculations is 45% of what number of inoculations? All right. Be sure to read this carefully and set up this problem. All right. So let's give that a go. So let's try letter C. And let's Let's try letter C and post your answers there in the chat. I'm going to come out here just a little bit more so you can get a look at the last problem there. Okay. That should give you a good template about what to do. Give yourself a reminder. Okay, well, Les says 1480. All right. See if other answers there in the chat. All right, Yvonne got 1480. All right. Wait just another minute here. See if anybody else could replicate that. Good. All right. Ready for turkey chili. All right. Okay. Let's take a good look here. See if we indeed get 1480. All right. And let's see what happens. All right. So we have 666 inoculations is 45% of what number? So we have 666 is equals 45%. So 45% here, remember, is 0.45. 45% of what number of inoculations? So of means times, and what number means x. We have 0.45x here on the right-hand side. Go ahead and divide by 0.45 on both sides. All right, do that really quick. All right, and so indeed we get 1480 here as our final answer. Good stuff. Okay, are there any questions so far about that? Or anything else I should mention? Any questions so far from anyone? Again, type no in the chat if you have no questions, and we'll move on. Okay. No. All right. Okay, let's move on then. All right. Now we're going into finding percentages territory here. All right. Again, we want to go ahead and proceed to do these problems here the same way we did the last few problems here. The only difference is that now we're not actually converting the percentages into decimals because we actually need to find the percentages outright. So let's see how it works here in this problem. We'll look at a couple problems here. We'll do them together, and I'll have you guys give it a couple of try. So it says 13 auto mechanics is what percent of 52 auto mechanics? Okay. Again, just interpret our words here. We have 13 auto mechanics, so put 13 here, is, yeah, Sorry, Yvonne. There we go. All right. So we have 13 equals what percent? Now again, even if it's what percent or what number, it doesn't matter. This what percent what number is still going to be x, okay? Because I don't know what it is, okay? Since I don't know what it is, then I'm just still going to call it x, regardless of whatever it's determining, okay? And I'm going to say of 52 auto mechanics, so 52. So to clean this up a little bit, this is what we're going to have. We're going to have 13 equals 52x. Now, to proceed, we're still going to do the same exact thing. I need to solve for x. Okay. So we're going to divide by 52 here, just like so. Now, I have a full expectation here of getting a decimal. Okay, it's possible we could get a decimal here. More than likely, we will. So if we do 13 divided by 52 on a calculator here, let's do that real fast. Okay, so we get here is 0.25 equals x. Okay, so I do want to make this a decimal here at the end of the day. All right, and then let's talk about one of the big keys here in a problem like this. And let's go ahead. Yes, thanks. Okay. Once you find the decimal answer, convert to percentage. So if we're going to find the percentage here appropriately, we just convert this 25% here, or this 0.25 into 25%. So this is going to be 25%. Again, how do we convert this into a percentage? Again, one more time here, that down. So to convert to percentage, move the decimal place over to the right 2 places, okay, from the decimal. I should say. All right. All right. That's all we're going to do here is I'll just leave it like that. It's just a lot easier. All right. So as you can see here, 0.25, you move it over 2 spots, and you get 25% as your final answer for this problem. Now, this works both ways. So I'm going to show you the next one here as well. So here, let's take a look at letter C. It says, what percent of $300 is $390? Okay, seems fair. So we say, all right, well, what percent are we looking at here? Okay, so what percent? So that means, again, what percent means X. I don't know what it is, but we'll just call it X. Of means times, and we have 300. Is means equals 390. So just cleaning this up a little bit, we get 300x equals 390. Then we'll just divide by 300 on both sides. And again, it's entirely possible for us to get a decimal that is above 1. That's perfectly fine here too. So here we get x is equal to 1.3. Now, can anybody tell me, what is 1.3 as a percentage? What is 1.3 as a percentage? Uh, Other way around, Yvonne. You did it Wrong way, Yvonne. Again, read the note here. You got to convert to a percentage. You have to move the decimal place over to the right 2 places. We're going from decimal to percent, not percent to decimal. So what's 1.3 going to be in percentage then? That'd be helpful, actually. 130%. That's correct. Actually, let's see here. Maybe my camera's in the way. So. All right, there we go. I can zoom in off of that. That's too much. I'll figure it out. All right. So this will be 130%. That would be correct. Yes. All right. So that's our answer here, 130%. Good. All right. Let's have you guys take a look here at a couple of these problems. All right. And I'll have you try both of them here. So try number 2. And, well, actually, just one of these is fine. No, 2 of them. Gotta do 2 of them. Try number 2 and 3. So I can fit them on the screen here. So let's try number 2 and 3 here. All right. Let's take a couple minutes here. Let's see what we get here for 2 and 3. Then we'll move on to the next section. So again, once you have an answer for 2 and 3 here, please post that in the chat. All right, you get 40 and 140%. Okay. See if we have any other answers here. So for the subsequent ones, 40 and 140%, that's fine. Okay, that's fine. Not a problem. Move on. 2.4 and 3.14%. Seem a little bit low, Ola. Oh, whoops, 2 is 40. Oh, I was like, oh, okay. All right, I totally read those wrong. Okay, my bad, my bad. My bad, Ola, my bad. I was like, wait, 2.4%, where did we get this from? Okay, no, I totally read those wrong. All right. That was a classic dumb moment brought to you by me. Um, all right, that was yeah. I'm not smart. we'll just we'll just run with it. I'm not smart. There we go. All right. Okay. So let's take a look and see if those answers are correct. Indeed. All right. So let's take a gander. See what we get. So we have 34 post office boxes. So 34 is what percent X of times 85? So 34 equals 85X. Divide by 85 on both sides. All right, so hip bop boop on the calculator there. All right, so we're going to get 0.4 here is equal to X, or again, converting that over, 0.4 is 1, 2. That's going to be 40%. Okay, so 40% is indeed the correct answer. All right, number 3, what percent of 920 invitations is 1288? So what percent is X? Of means times. 920 is equals 1288. We have 920x equals 1288. So divide by 920. And here in this case, let's go ahead and again, just quickly do that out. And so here we're going to get 1.4. Or again, moving that over, we get 140%. So both of you are correct on both of your answers. Great. All right, good stuff. So that's the end of section 6.5. All right, now that we have a good idea about how to set it up the decimal way, we know how to set it up the proportion way. Okay, so we have both methods in the bank here for us to do. Again, we can now approach problems, in a different light. Depending on which method that you find most comfortable is the method that you're probably going to run with. Now, in section 6.6, as you see here, we're going to be talking about special application problems here with percentages. Okay, so things that we see quite a bit, in comparison to things we see quite a bit in the real world, I guess is the easiest way to put it. So the first one that we see here is the sales tax. Now, sales tax, as you know here, is added on to every percentage is added on to every item, the total amount of items that you buy. So if you want to solve the sales tax here specifically, the sales tax formula, Sales tax amount is going to equal the total for your items multiplied by the sales tax rate in decimal. Okay, so that's the sales tax amount here. Take the total number of your items there, multiply it by the sales tax rate in decimal, and there you go. Winner, winner, chicken dinner. It's really not that hard. You just got to plop in the numbers where they need to go. So for example there, look at this problem here. Office Max sells a laptop computer for $499. If the sales tax rate is 5%, how much tax is paid? Okay, what's the total cost of the laptop? Well, if sales tax amount, we got the total number of items, which is just one. So our laptop here is $499. We're now going to multiply that by the sales tax rate in decimal. So our sales tax rate is given to us as 5%. 5% here is going to be labeled as 0.05. So this is going to be our sales tax amount. So again, you can plug that in the calculator there. Let's see what we get. So we get 499 plus times 0.05, sorry, not plus 0.05. So here we get 24.95. So this is going to be our sales tax amount. That's what you see on a receipt, before you pay all the monies. You're like, okay, you get charged $24.95 for sales tax on a $4.99 item. Find the total cost here, the total cost of the laptop. The total cost here is going to be, this is with sales tax, okay, included. So here we get $4.99 plus $24.95. So at the end of the day here, you're going to owe $523.95. So total amount for your sales tax, use the formula here, and then our total here, what we pay, what the cashier says to us here, that's going to be $523.95, and that's your final answer here for this problem. Okay. All right. Let's have you guys try the next one here. So let's take letter C. So you're buying a car. You suppose the sales tax rate in your state is 6%. Find the amount of tax and the total you would pay for each item. Let's say we're trying to buy a pickup truck for $24,500 and our sales tax rate is 6%. Let's have you guys take a minute or so. Let's have you guys try and find out what the sales tax would be total and the overall price the total price that you pay with the sales tax included. Oh, I'm going to zoom out here for just a second. So we can, again, you can get a good look here. This is the formula that you see up here. So again, use that formula to your advantage. You haven't written that down. Now you can try the $24,500. Zoom out just a bit. I can get that in. There we go. I know this will be a little bit hard to see, but I just want to be sure that you have the formula there on the same page. Once you have your answers there, go ahead and post them in the chat. Okay, you get 25,970. That's the total. Now, how much in sales tax did you pay there, Yvonne? So if I say that's the total that you paid there for the truck, that's fine. But how much in sales tax did you pay to get to that total? Oh, that's fine. That's why I ask. It's just that they asked two separate parts here, so it's not your fault. All right. Anyone else? All right. Let's take a good look here at this problem. There we go. All right. Let's look at this pickup truck at 6% sales tax. You didn't get it right away. That's fine. We'll go through this again anyway. Okay. So we're looking for a $24,500 pickup truck. So in this case, we're going to take 24,500. We're going to multiply that by 0.06, which is going to be our sales tax here for 6%. Again, just like we did before, convert that percentage into decimal. Okay. So let me put that as a note. All right. And so here we get, let's go ahead and figure that out here. So this indeed is going to be $14.70 for our sales tax. And so our total price here is going to be $24,500 plus $14.70. And that's going to equal, again, the, let's see, just really quick, make sure I'm not messing up in my head. 25,970 is correct. All right. All right, good stuff. Nice. All right, excellent. Now it also works the same way here. Again, the sales tax on a $24,200 Ford Escape is $1,573. Find the rate of the sales tax. So in this case here, they tell us what this amount of sales tax is going to be. So again, using the formula here that we have kind of a couple pages before, we're going to take the amount of the sales tax that we get here is equal to the total price for the item, which is $24,200. And then we're going to multiply that by X, which is going to be our sales tax rate. We'll divide by 24,200 here on both sides. And so here we're going to get a value for x, so let's find out what that is. And so here we get 0.065 as a result. Hey, no problem, Connor, my dude. Anytime. James deserves it, man. He's a good dude. Definitely a good dude. .065 here is going to be the same as, let's go 1, 2, 6.5%. All right, so 6.5% will be our answer here for the sales tax rate for this particular car. All right, there we go. All right, good stuff. All right, I'm kind of running out of time here, so I know I'm kind of going a little fast here in this case. I do apologize. Guess I'll have you guys try that on your own there. Okay. Commission formula here. I'm not going to spend too much time on commission, but the way how commission works is basically it works like this. The amount of money, the amount of commission that you make, if you want to know the commission formula, the amount of commission that you make is equivalent to, again, the total amount of sales, so your commission rate, percentage in decimal, I guess I'll put it that way, times your total sales. All right, so that's how it's going to work here, at least in this case. The amount of commission here is equal to the commission rate percentage in decimal times your total sales, and then that's what you're going to get here in that case. So if you want to just quickly do this one out, I'll just quickly do this out here really fast, and I'm going to kind of move on. So in this particular instance, if we want to figure out how much they make in commission, well, you take your total sales here, which is, whatever my commission rate is here is 42,500 is how much I made in sales. And then I multiply that by our commission rate, which is 9%. So I take 0.09 here. Gosh. All right. And we go ahead and multiply that together. So our commission here is, this is how much money we would make in commission. It would be $3,825. Okay, so if we use the formula there, that's essentially what we're doing. There's not much to it outside of that, and it works pretty much the same way as sales tax. So that's why I'm not going to focus on it too much, because the commission formula and the problems here are pretty much one and the same as the sales tax formulas. So yeah, there's definitely that. So I'm going to kind of move on here for that. Rate of commission ones are the same thing. So okay. Now what is important though are the last couple parts here, which are probably the most relevant. So let's talk about the relevancy behind the last two parts. Now, if you do any shopping at any moment in time, I think you could all agree here that if we shop, well, sale prices and markups are certainly the most important thing that we want to be on the lookout for. So that's what we're going to look at here is a discount formula here, or the sale price formula. Let's talk about how it works here in this case. So the sale price of any item, if we look at the formula here, is equal to the original price minus its discount. That's how much money we would save on that particular item. For example, it could be a clearance item, and you could be like, oh, okay, you take X amount of percent off, and then that's what the price is on clearance, or whatever the case may be. Now, this is kind of like, this is a little bit deceptive, though. Although this is what they technically say here, like in the book, what you really want to look at here is you want to look at it this way. The sale price here is equal to the original price. We still need the original price. Now, the discount, though, is going to be a little bit different. I'm going to reflect the discount like this. It's going to be the original price times the sales percent in decimal. So to get the actual discount here, we take the original price, multiply it by the percent off that we want to take for that item in decimal, and then once we subtract them from each other, that's how we get a sales price at the end of the day. So the sales price here, for example, for this, let's read this example off here. It says, Whiting Oak Furniture Store has a home entertainment cabinet with an original price of $840 on sale at 15% off. Find the sale price of the cabinet. Okay, so if we follow this second formula that we see up here, the second formula here will make things significantly easier. If I want to find that sale price, let's take that original price, which is $840, and now we're going to subtract it by, but now this case here, instead of confusing ourselves, let's just plop in the numbers exactly where they need to go in the formula here. So our original price here is $840, and we're going to multiply that by 15% off. Remember, 15% is 0.15 as a decimal. Notice, I want you to notice here though, notice I am putting these in parentheses, okay? Which means that, again, based on order of operations, we do need to do this first, okay? So we're going to get 840 minus, once we multiply that, so we get a discount here of 126 bucks. That's right, very nice, Yvonne. And then just take that 840 minus 126 straight up. So here we get $714. So $714 is our new sale price based on how much percent off we give. And you can see how easy that the formula actually, if we write the formula that way, you can see how easy we just simply found the sale price right away. Oh yeah, sorry about that. My fault. I apologize. I keep forgetting that my big head's in the way. Let me shrink down the camera a bit. Yeah. Maybe a little bit bigger like that. Yeah, no problem. No problem at all. Okay, let's look at another one here. Let's have you guys give this a try this time. This time is a you try, because I feel that these are more important. So let's look at number one. Number one, an Easy Boy leather recliner, originally priced at $950, is offered at a 42% discount. All right, so we want to find the sale price after this 42% discount. Okay. Once you have an answer for that, go ahead and post that in the chat. We'll go ahead and zoom out here just a little bit though. there's the formula up top. So let's go ahead and post it in chat when you have an answer. Okay. Let's see if that is indeed the case. Looks good though, Yvonne. All right. So an Easy Boy leather recliner originally priced at $950 is offered at a 42% discount. Let's find our sales price here. Our sale price, I should say. So that's going to be $950, our original price, minus $950 times 42%, which is 0.42. So again, just doing this out here really quick, 950 times 0.42. That is indeed correct, $399. All right, and go ahead and just subtract those. So correct here, 551, going to be our sale price. So our discount amount here is $399. Sale price here being $551. Bada bing, bada boom. Got it. Cool. All right. Okay. Finally, the last one that I want to cover here is this last part here. And I know I've been going a little fast, but I do need to get this section done. So it says find the percentage increase or find the percentage decrease. Now, in actuality, there's an actual way you can actually just figure this out here fairly quickly. It's actually not as bad as it may seem. So, oh, I guess we have a little bit more to do after that. Oh, I didn't know. Well, simple interest. I forgot there was a next section after that. Actually, that does change things. I thought 6.6 was the last section. Oh, you can do 6.8 as well. The real question is, actually, this is actually a relevant question for class. Give me a second. This is something I totally forgot about. It's not that I can't do it, it's just there's certain things I don't want to spend too much time on. Okay, that's fine. All right, that's okay. Oh, I forgot to add that. Okay, that's all right. All right, that's okay. So yeah, I'm just gonna skip those two. All right. Sorry, I had to check that really fast because I have to skip those two, but I'm gonna probably keep this one up to, not gonna do simple interest, not that. Okay, so this will be, all right. So let me, sorry, I was just checking the assignments there on my math lab, and I guess one thing I forgot is to add 6.6 as an assignment. So I'm gonna add 6.6 there today at some point to add as the last assignment there for chapter 6 test. But let me go ahead and talk about this last part here as the last part for 6.6. All right, so if we want to find the percent increase or the percent decrease, we're going to use a formula here in this case as well. So the way we want to do this is we want to do this appropriately. All we're going to do here, we want to find the so the way we do this is fairly simple. All we take is the new value minus the old value. All right, and we're going to divide by the old value. Now, I do want to point out one thing here. Note, we will get a decimal for this, so convert to percentage after. Okay. So really quick here, for example, attendance at a county park climbed from 18,300 to 56,000. Find the percent increase. So the new value here, specifically, okay, so in this case here, the new value is 56,000. That's going to be the new value. The old value here is 18,300. I guess it'll have to be this last one here. So, all right. So we're going to take the new minus the old. All right. We want to do that first in its own set of parentheses. And we'll divide that by the old value here of 18,300. So in this case here, again, we just want to subtract first. And then go ahead and get 38,430 on the top. Divide by that 18,300. And so here we get 2.1. Now 2.1 is not the percentage here, but it is a decimal that reflects the percentage. So our real percentage here, if we move this over 2 spots, is going to be 210%. Okay, so that's how you can find, say, the percentage increase or the percentage decrease. You may end up with a minus answer, but that reflects a percentage decrease at the end of the day. Which is going to lead us into our next topic, which is chapter 9, the last chapter, which is going to be positive and negative numbers. So we'll probably combine that for next time there. Now, really quick here, and I know I've kind of ran way over time here, but really quick, I'm gonna be putting up a test here. Now that test will not be due next week. That test actually will be due, yeah. I want you to enjoy your holiday rather than worry about some dumb test. Yeah. Yeah, so here's what I'm going to do. I'm going to post the test later this week. So I will post the test later this week, but it'll be due on the 6th, okay? Can I leave 5 open so you can attempt one more time? Did you do chapter 5 there? At least I hope you did. Let me check for just a second, Yvonne, and I'll answer your question. Okay. Okay, I'll give you until tomorrow there, Yvonne, to finish. One more attempt. Till tomorrow. Okay. Okay. What's this? And this needs to be done by all right, there we go. By tomorrow. Save that. There you go. All right, all done. All right. All right, there we go. Apologies for going a little overtime here. That's again on me. Um, but again, that will take care of things here for today. I know I kind of went fast here over the last couple of sections. Kind of have a little bit to do here with this 6-6, so I'll just make up an assignment here. There won't be too many questions for 6-6, so I'm not going to go super hard. Yeah, so chapter 6 will only go up to 6-6. Yeah. We just don't have time for the last two because I do want to go over positive and negative numbers in chapter 9. So that's going to have to take priority. So you cut content, you cut content. It is what it is. So obviously I won't test you over any cut content. So that's an unreasonable expectation. So any sections we don't cover will not be on the test. Any topics we skip probably will not be on the test. That way it's fair. So okay, so I'm going to leave off here for today. And again, I'm going to keep the stream running here because we have an 11 o'clock class there. Everyone, have yourself a very wonderful Thanksgiving holiday. Okay, please take care of yourselves. Have a nice time with some family. All right, hopefully you have a little bit of nice food as well. All right, again, stay safe, stay healthy, and stay sane. All right. Am I teaching 096 next semester? Unfortunately, not. I will not be teaching 096 next semester. They've given me all my classes are statistics classes next semester. But if there's something that I can at least tell you, Eric, is that if you guys do need my help next semester about whatever topic, feel free to contact me, and I'll be more than happy to help you. Okay. Just because you're not in my class doesn't mean I don't suddenly not help you. So you can always ask me if you always feel confused, okay? Hey, of course. So I'm here. Remember, I'm here to take care of you guys, so that way you guys can move up that math ladder. Get out doing more math after some time than doing what you need to be doing. So All right. Well, guys, have yourself a great holiday. Okay, I'm going to just switch this over to the background. You have a wonderful day, Eric, too, my friend. All right, let me switch over the background. I'll be back in 10 minutes. Right? All right, everybody. Hello, hello, hello. Sorry for the late start here, but my first class ran way over time. And, well, yeah, that kind of happened. All right. In any case, though, um, good morning, Samantha. How are you? I hope you're doing really well. Good, good. I'm glad you guys stuck around here. There's a few things that we'll need to talk about, but, yeah, we'll, get going with that. So, no worries, no worries, no worries. We'll be all right. Good, good. All right. Well, let's get going here. You guys have been very patient here. Just getting some things squared away on my end. So now that I got things squared away on my end, boop, 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 boop. All right. Good morning, Robert. Good morning, my friend. How are you? How are you? Sion, good morning. Good morning to you. How are you? Good. Yeah, I'm doing really good. Doing really good. It's been a little tiring today, to be honest, but you know what? That's what happens when you have a lot of material kind of packed in. So, good morning, Patricia. How are you? Yeah, it's been a very eventful morning to say the least, with just a lot of stuff that you had to kind of do. But got a couple things clear that. Loving the snow. Did it snow outside? I haven't even looked outside today. So is it really snowing? Now I gotta check. Hey, you make me curious. All right, let me check here. There's snow outside. Oh yeah, look at that. All right, look at that snow. Look at that snow. I was like, oh, you can tell how often I look outside, as in, yeah, unless I have to go outside, I just don't. That's okay though. Hopefully, we'll be okay. 6 tons? Seriously? 6 tons? Dang. What have I been doing with my life? 6 tons. Holy smokes. Wow. Yeah, I probably wouldn't never want to leave. It's like if I had to go face to face with a Cayman and be like, yeah, no, think I'm out, bro. You take that. Like, just casually walk away from a 36-foot long Cayman with a 6 ton in weight and probably jaws that can rip you in half. Love those facts of the day, though. Respect. Um, all right, guys. Let's go ahead and do this here. We're gonna wait long enough here. All right. Okay, let's get started today. Welcome back. Welcome back to Tuesday here. This is the only time we're going to be meeting this week. But in any case, I hope everybody had a great weekend in the meantime. All right. Um, so yeah, a couple of things that we're going to have to talk about. A couple things here. First and foremost here, we're going to be doing the latter part of section 6.5 and 6.6. We're going to do part of 6.6 now. One thing that I discovered here from my last class is that I didn't have the homework there for 6.6 posted, so I'm going to have to make that assignment up, and I'll post that here up probably later today. We'll also be doing a test here for Chapter 6. That I've decided that the test for Chapter 6 here will be due on the 6th of December, so that is like a Sunday. So um, the Chapter 6 test is due on the 6th of December. Now, I haven't actually made it up yet, so that's why I'm kind of pushing it back to like that Sunday there. I haven't actually made it up yet. So once I make it up with, of course, the practice test that goes along with that, then that's how it's going to be. Didn't we just have a test? Yes. We actually have two more tests before the final. So yeah, it's kind of like the next two tests cover the next two chapters, and then we'll have a final. So just to let you know. So uh, honestly, it shouldn't be. It's not going to be overly that hard to do. So I'm just I'll have some more. I'm killing you here, Smalls. Sorry. It's the part of the year where I'm gonna have to be like, yeah, that's a thing. I'm pretty sure we'll have more to talk about once, once once the Thanksgiving break is over. But I didn't want to make the test like due next Friday because it's right after we get off. So I'm like, oh, make it due next Monday or next Sunday. That makes more sense. Yeah. We all got to do the work sometime, though, ladies and gentlemen. That's the thing. So, I wanted to make the least that formal announcement. I made that announcement in my last class, and I'll make that formal announcement now. Is that once those are posted and everything like that, you'll get an email regarding that, and then you can work on the Chapter 6 test there. But we're going to finish up Chapter 6 here for today. In the meantime, regardless of that fact. Okay, so that's the plan here for the most part. Okay, so let's go ahead and get started there. All right. Does anybody have any questions, by the way, um, before I get started? None? Okay. All right. Well, let's go ahead and give it a go, and let's see what we're working with. All right. So today, we're gonna. Do I have office hours here today? Yes. Yes, I do. If you have a question or so, please feel free to ask. Okay. Okay. So today, what we're going to be starting with here is we're going to be starting with the second method here for doing our percentage problems. Last time we looked at proportions here and how to set up percentage problems. And today we're going to be working with the other method here that has to do with percentage problems. And that is, again, converting it into decimal and whatnot. So again, let's talk about one of the keys here. This is for the method where we convert percentages into decimal. Okay. Now remember here, so note, remember to convert from percent decimal. We move the decimal place over 2 places to the left. Okay. So if we want to convert from a percent to a decimal, we move 2 decimal places over to the left. Now we also can't forget about 2 other important things here. Let's talk about key number 1. Key number 1 here is, of course, knowing how the language is going to work. So one of the things that we're going to focus on here is a lot of the language to set up our problems here when it comes to percentages. Okay, so let me go ahead and show that off here with, let me switch over here to the main screen. There we are. All right. Yeah, no, I was like, wait, I see my face, but it's too large. All right. Why is my face so big? All right. Why is my head so small when people see me in public, though? All right. Anyway, um, key number 1 here is remembering that the word of here means the word of. Of means to multiply. Okay. And key number 2 here is that the word is means equals. Okay. So of means multiply, and is means equals at the end of the day. All right. So let's go ahead and take a look at this problem here. Again, we're just going to break it down one piece at a time, okay? So it says find 15% of $160. So the first things first here, we're going to take 15%. Now remember how it works for 15%. 15% is if we need to convert this into a decimal. So since this is the second method where we convert percentages into decimal, we want to be sure to write the key here, write the percent as a decimal before using the equation. So that's essentially what we're going to be doing here for each one of these problems, is that part equals percent times whole, where that percent is going to be written as a decimal. Now, 15% is we start with the decimal point here to the left, to the right, move to the left 2 spots, And so here we get 0.15 to reflect a decimal equivalent here for 15%. So we're going to get 0.15. I accidentally wrote. So 0.15 of, again, of means times, and then 150. So we just do that on the calculator there, 0.15. I don't really like how that's written there, but okay, that's correct. Times 160, sorry, my fault, I wrote 150. There should be a 6, all right. So the answer is indeed 24. That part is definitely true. Okay, good. So albeit it's not too hard, but again, the setup here is going to be the key crux for doing a lot of these different types of word problems that we're going to be looking at here today. And there are quite a few. So again, I'm going to go through it methodically here to get to what we want. Let's take a look here at letter C. Let's take a letter C. Find 0.4% of 250 patients. All right. So it was good. Yeah, that's fine. Okay. So let's write in 0.4% here. How do I write 0.4% as a decimal? How do I write 0.4% as a decimal? Because we got to convert the percentage here into decimal. So how do we write 0.4% as a decimal? 0.04? Patricia, I want 0.4% as a decimal there. You wrote just a percent. I'm like, 4% is 0.4%? Like, uh-oh. That's if you're going from decimal to percent. That's true. Okay. 0.004. And we got 0.04. All right. So the reason why I asked this question here, 0.004, is that this is a trap. This is definitely a trap, as Admiral Akbar likes to say. All right, it's a trap. All right, so this is one of those things that why I put this note down specifically. If you're going to convert the percent to decimal, you have to move that over 2 places to the left. You know, you can't make assumptions here. That's one of the most important parts. You start with 0.4, and you got to move that over 2 spots to the left. So you move 1 and 2. And so that's where you're going to get 0.04 here. So 0.004. See, look at it, even I do it. I'm dumb as bricks, and everybody knows it. So yeah, just note to self. This is what you're going to write for my, rate my professor stuff. So make sure you get this right. Make sure you note this moment of stupidity. All right, so 0.004 is correct. Be like, rate my professor. What do I think about your professor? He's dumb as bricks. I don't know why he's my professor. Okay, that's fine. So, all right. So 0.04 here of being times, and then 250. All right. So again, you can plug that in the calculator there. All right. So you get 0.004 times 250. And what do we get here? Once we multiply? 1. That's correct. So the answer is indeed 1. All right. Good. All right. Any questions about that? Nope. All right. Okay. Now, I want you guys to try one more here. This time it's a Can I show the note again? Sure. Right there. There you go. Move that away from my face. Hopefully that's a bit easier to see. Yeah, of course. Of course. I would think the same thing. All right. Hopefully we got that. All right. Now I do want you guys to try a problem here. I want you to try number 4 here. So take a minute here. I want you to try number 4. 135% of $1,080. Okay? Again, you need to convert 135% into a decimal and then going ahead and do the rest. Okay? Once you have an answer there, we'll take a quick minute here. Once you have an answer there, go ahead and post that in the chat. All right, 1458. All right. Okay, let's go ahead and take a look here because we got a few answers here. That's fine. Hopefully you guys will maybe get the same thing. We'll take a gander. Now, 135% here. All right, Sion got that as well. Good, good. 135% is moving over here. All right, moving over 2 spots. So we get 1.35. I got another 1458. Just Castro there. All right, so got 1.35 of times 1080. Okay, so here again, you can bip bop boop and all that stuff. So so the key here is really the 1.35 part. Is just recognizing, remember, we can also have percentages that are above 100%. Okay, so that's perfectly fine here. So again, the answer is indeed 1458. That is correct. Okay, so as we mentioned here before, of means to multiply and is means equals. Okay, so just like we talked about before. Now, we're going to piggyback off of that last example here just a little bit. And also these two words that we've talked about extensively, of and is. And of looks pretty awful, so let's rewrite that. Otherwise, that'll bother me to no end. All right. Of is. All right. So in this case here, we have 8% of 8%. 8 tables of 4% is 8%. 8%. Gosh. Hang on a second, folks. I'm reading 4 things at once, and I cannot read letters at this moment. Give me a second here. Give me a second. All right. Blah 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 blah. Blah. Go. Let's go all the way back to reading. Okay. All right. 8 tables is 4% of what number of tables? All right. 8 tables is 4% of what number of tables? All right. Now, the first thing that we want to do here is we're going to use our keywords here to kind of help set us up our problem here. So in this case, it says 8 tables, so 8. We'll bring down the 8. is, and remember we said is means equals. Go over this together here. The is means equals. Now, one thing to remind ourselves here, just like we did in the previous problems here, we said 4%. So if we talk about 4% here, okay, reminder here, note, remember to change percent to decimal for all problems. Okay, so we want to change percent to decimal here for all problems. If we have to use it in the process of calculation. All right. So 4%, really quick. 4% we can write as 0.04. So 0.04 here is 4% as a decimal of, now this of here again means to multiply, of what number? So here we have what number of tables. Now it doesn't matter what number of whatever, and really honestly doesn't matter. All we do know is that what number of whatever is just going to be our unknown value here of x. Do you need the 0 before the point? Oh, I use that just as a, I just commonly use 0 point whatever. That's just a habit of mine. You could technically write 0.04 and it would be the same thing. So there's no difference between 0.04 and 0.04. Just a habit I picked up on since I use a lot of decimals. So I'm like, okay, pretty much. I'm like, okay, if it's 3.54, then I just write it the same way. So go with whatever way that you feel comfortable with, though. Totally up to you, Samantha. Okay. So we have 8 here is equal to 0.04 x. Now, let's recall what we did here for the algebra from last time. So what do you think about this? How do we solve for x here? What do we do? What do we do in order to solve for x in this case? Make that a bit bigger. How do we solve for x? Remember that we have to use our, kind of little bit of algebra from before. So how do we solve for x in this equation? 8 equals 0.04x. All right, divide both sides by 0.04. Very good. All right, everybody's on the ball here. All right. I'm liking that a lot. All right. So can anybody give me an answer here? 8 divided by 0.04? $200, that's correct. Nice. All right, 200 spot on, everybody. Very, very good. Okay, and that's how we can solve for that. So again, all these problems here are going to revolve around, again, just using our keywords there, converting that percentage, in this case, the percentage, and then finding our final answer for that. All right, let's have you guys try one now. Let's have you guys try letter C. Let's have you guys try letter C here. 8.5% of what number is 102? So go ahead and give that a try. Again, if you're not comfortable with 8.5%, another way to write 8.5% is 8.5%. That'll make it a lot easier on you in this problem out. If you had mixed numbers like this, just convert it to its decimal equivalent. And then just roll from there. Once you have an answer there, go ahead and post that in the chat. Oh, so we got 1200. All right. Any other answers here? 12. All right. 1200, Robert says. All right, good. All right. Well, let's take a gander here, shall we? Okay, so 8.5%, 8.5%. So again, 8.5% can be going to the left here, 1 and 2. So here we get 0.085 here for our decimal. Of means times. What number? What number means x? Is means equals 102. So we got that part down, and you're in really good shape. We're going to divide by 0.085. And if we do that there, we're going to end up with exactly 1200, which is the correct answer. So if you got 1200 there, good job. You got it. Let me ask a question here for some people. Did some people get 12 as your answer? I know the people who posted here got 1200, but did other people get 12 as your answer? Maybe you're surprised to see 1200 as opposed to 12. If no, you got a decimal. You got a decimal. What did you do, Samantha? Did you do like 102 divided by 0.85 instead of 0.085? You forgot x. Oh, well, that's kind of a problem there. Can't forget about can't forget about x there. So you got it. That's why take a look at the process there. 102 divided by 0.085. One of the things that I do want to point out here, this actually happened in the first class. So they got a couple of people got 12 as their answer. I'm gonna put this as a note. You cannot assume that you will always multiply the percentage by the number given. Okay. Read the problem carefully to interpret where things need to go. Okay. So one of the things that is important here is that you can never make assumptions in mathematics. And you says, oh, numbers always have to go here, here, and here. Because that's, you have to look at how it's written. And then once you go ahead and do that, then you can go ahead and apply the process to that. But you can't make the assumption that it's always going to be the same way in the same spots every single time. Because again, the information that they could give you is different, could be different from problem to problem. So that's why I'm kind of stress that point there. How the problem's also written also does matter here as well. Let's try another one. Let's have you guys try letter C here. Let's take another minute for this one. 666 inoculations is 45% of what number of inoculations? Again, once you have an answer there, post it in the chat. Yeah, I can scroll up. Actually, let me zoom out for you, Samantha. Sorry. Here you go. All right, Patricia got 1480. Yeah, no worries. Okay, 1480. 299.7. You took 45% and multiplied by 666. Samantha, you did the same thing that I basically mentioned here in the note. You'll not always multiply the percentage by the number given. You're making that assumption and you're falling for the trap. Try again. You need to break that bad habits. Bad habits need to go away. That's why we gotta smooth out them wrinkles. That's why I always say it's always about the setup here more than it is about like saying it's gonna go a certain way. All right. Let's take a look here. We have 666 inoculations. So we have 666 here. Well, okay, Samantha, take a look at the question here. All right. So it says 666 inoculations is 45% of what number of inoculations? Number one, again, don't assume that you multiply the percentage times the number. You have to take that out of your mind. You have to look at the words that are listed there right in front of you in this word problem. Okay, so I'm looking at this one piece at a time, okay? I'm not looking at this as that this has got to happen and then I'm done. That's not what I'm going to be looking at here. Instead, my thought process is when I look at a problem like this, I say, all right, well, let me see what exactly the wording of the problem says and then set up an equation around that first before I do anything else. So I understand if you want to go from 0 to 60 right away, but I'm not going to ask you to do that here. If you want to, one of the things that you can best improve upon, and this subject can be really tough, I'm not going to lie. So one of the things that really helped me improve is just saying, okay, let me look at the problem here carefully and let's break it down one piece at a time and then put it together. Like regardless of how complicated the problem was, that's the thing that I kind of like to do is basically break it down into small little pieces and then once I have all the pieces put together, I'm like, okay, now I can go ahead and do what I want to do. So like in this problem here, it says 666 inoculations, okay, whatever, it doesn't really matter, is. Now is, as we talked about here, is means equals. So that's exactly what I'm going to put here. 666 inoculations is. That's just looking at the language, just outright. Now I look at 45%. I said 45%. Well, 45% as a decimal is indeed going to be 0.45. I'm going to get 0.45 here. Now I have the word of. Of means to multiply. I'm just going to write multiply right here. And then I have what number. And what number we always indicated as x. So here I'm going to get 666 equals 0.45 x, okay? And now we just solve for x here by dividing by 0.45 on both sides. And so if we do that out, we then get exactly as stated here, 1480 as our final answer. So remember here, one of the most important things in these problems, regardless of how how crazy they look, is you can't make the assumption that certain things are going to happen a certain way. Read the problem first, and then go ahead and put it together. Then do the calculation after that. I'll guarantee you it's one of the most helpful things that makes this subject make a whole lot more sense is when you just slow things down. No need to accelerate, just slow things down. Are there any questions about that? Okay. Does that make sense, Samantha? I want to be sure that hopefully that process makes sense. I don't mean to be like tough. I just want to be like, hey, those kind of, I just want to be sure that, we can, again, smooth out those wrinkles there so it's not like super overwhelming. Okay, let's look at the next type of question here. Okay, so in these particular word problems here, we're just trying to find the percentage. So there is one note that I'm going to make here in this case. All right. The key here in this case is to convert, so we're going to get a decimal here. The key is to convert the decimal into a percentage at the end of the problem. So we don't know what percentage that we're going to find here. We're going to set up the problem, of course. But whatever we get as a decimal there, we're going to go ahead and convert it into a percentage at the end of the problem. And then we should be okay. All right. So it says 13 auto mechanics is what percent of 52 auto mechanics? So let's just take a look here at each one. We have 13 auto mechanics. So we're going to bring down 13 here. Now, I don't care what 13 represents here, but what I do care about is the word is, which means equals. Remember, what percent here represents x, since we don't know what that is. Of means times, and 52. So here we get 13 is equal to 52x. We'll divide by 52 on both sides. Now, you have the full expectation here to get a decimal, so that's fine. You will definitely get a decimal here when you do 13 divided by 52. That part is definitely true. Okay. And so what we get here specifically is we get 0.25, which equals x. Well, remember our key here. Our key says to convert the decimal into a percentage at the end of the problem. So here we have the decimal equivalent. The decimal equivalent here is 0.25. Remember to convert percentage, and let's add that as a note. That's okay. So to convert decimal to percentage, move the decimal place to the right 2 places. So in this case here, 0.25 here specifically, if we move it 1, 2, that's going to be equal to 25%, which will be our final answer. Okay? All right. Okay, so that's what we get for our final answer there. All right. Now let's have you guys give one a try. Which one do I want you to do? Kind of like a specific one I want you to do. Yep. I want you guys to do number 3 here. So let's do number 3 here. What percent of 920 invitations is 1,288 invitations? So let's take a minute or so and give that a go. All right, and we'll see what we're working with here. So. Okay, 140% is what Patricia got. Okay. 71%. Okay. 140. Okay. Now Robert changed his answer to 140. I think he might have had the numbers reversed around. I think that was the problem. Okay, let's take a good look here. Let's see some good answers. So first of all, let's interpret the problem here. It says what percent? So we're going to call that x. Secondly is the word of. Of means times. 920 is means equals 1288. All right, so we get 920x is equal to 1288. So we divide by 920 on both sides. So x is equal to 1.4, but 1.4 is a decimal, and we need to convert over to a percentage. So we're going to again take that 1.4, going to move that over 2 spots here. And so here we get 140% as our final answer. Okay. Any questions about that? So 140% is the correct answer there. Done? All right. All right, let's move on here. That was the end of section 6.5. So we're going to move on here to applications of percentages here in this next section, just like so. So we're going to look at several applications regarding this. Some of this we'll go over a little bit fast, but I do apologize in advance. But I just need to kind of get this stuff out here, and then you'll have a chance to work on it with some applications in the homework and whatnot. So, all right, first and foremost here, let's talk about some of the basic applications here, first and foremost. So some of the basic applications that we could talk about when it comes to percentages, some of the more common ones here. First, finding sales tax. Now, everybody's paid sales tax. Again, sales tax is the money added on, to the amount of items that you buy. So at the grocery store, for example, you buy X amount of groceries, that's equal to some subtotal. Okay, and then sales tax is added in at the end of your receipt, and then that's how much you pay total for all your groceries, for example. Now, there is a sales tax formula that we use, of course, to figure out how much we're going to pay. So let's say we have, again, the amount, we have the sales tax amount. This is going to be equal to the total for your items. And then we multiply that by the sales tax rate in decimal. So one of the things that's important here, just like the last section, we want to go ahead and put those percentages in decimal here in order to do our calculations out. And it shouldn't be too hard to figure out. So for example here, let's look at this first one. Office Max sells a laptop computer for $499. If the sales tax rate is 5%, how much tax is paid? What's the total cost of the laptop? Okay. So in this case here, if we use the sales tax formula and the sales tax amount, the sales tax amount here, the total for the laptop here is $499. And we're going to multiply that by the sales tax rate, which is 5%, but we put that in decimal. 5% in decimal is 0.05. So we multiply those things together, and we have 499 times 0.05. Bippity boppity boop, and we get 24.95 here as the amount of sales tax that we get here for this problem. Now, I'm going to take 499 here. I'm going to add, again, I don't even know why I'm doing that, but okay, 24.95. So if we do that here, we're going to end up with an answer here of our total, which will be 523.95. So 523.95 is what we get here for our guy. So our total amount of sales tax here is $24.95, and our total that we pay at the register would be $523.95. Okay, so that's what we have here in this case. All right, let's move forward here. All right, let's have you guys try this really quick. We'll try letter C. So suppose the sales tax rate in your state is 6%. Find the amount of tax and the total you would pay for the item. So our sales tax rate is 6%, excuse me. And our item for this pickup truck is $24,500. So go ahead and give it a minute here. Once you have your answer there, post that in the chat. $25,970. Okay. All right. And how much in sales tax did they pay? So I agree. I agree with those answers there, where that's the total. How much in sales tax did they pay out of that amount? Definitely agree with those numbers that you guys are putting up. 1470. Okay, good. So I just want to point that out there because some of the problems on the homework may ask you, well, how much you pay in sales tax, and then how much was the total for the item. So okay, very good. Okay, good job, everybody. That is correct. So we take 24,500 here. We multiply it by the sales tax rate of 0.06 for 6%. All right, we indeed get $4,470. Add that together with the 24.5 pickup. And I totally agree here. We get 25,970. All right, good job, everybody. Nice. Okay. Now, remember, it can go the other way as well. Like, for example, here, this question. This question here asks for the actual sales tax rate. So it says the sales tax on a $24,200 Ford Escape is $1,573. Find the rate of the sales tax. So in this case, the formula is actually really helpful because it says the sales tax amount is equal to the total of the item times the sales tax rate in decimal. So in this case here, we're going to have our amount that we pay in sales tax, which is $1,573, equals 24,200, which is the price of the actual item in question, times X, which is our actual sales tax rate. And we just divide by 24,200 on both sides. Okay, and then here we get X is equal to 0.065. I think that was the answer. Then we convert that into a percentage. Yeah, thank you, Samantha. And so here we get 6.5% as our result here. All right. So that's our answer there for that problem. Now, I'm just going to leave that up there as again, a relative example here. Again, just using the formula and plopping stuff in. All right, I got to move forward here. Now, this is kind of like a little rushy, but unfortunately, I don't have as much time as I want. It's happened in the first class too. So commission. Now I'm not going to focus too much on this topic here because commission works pretty much the same way as sales tax. So um, if you want to find out how commission works, it's the same thing. The commission amount here is equal to your total sales, because that's how it usually works with commissions, however much you sell, and then you multiply that by your commission rate. In decimal. So again, just your amount that you get paid is based on how much you sell, and then that would essentially tell you how much you made in commission for the most part. So for example here, Lynn Cochran had automotive tool sales of 42,500 last month. Her commission rate is 9%. Find the amount. Find the amount of his commission. Whoops. So here, what we want to do is we want to do 42,500. Want to multiply that by 0.09. Again, same thing as we did for sales tax. Really, no difference at all. Okay, and then we get a commission amount here of $3,825. That's pretty much it. So same vein as sales tax. Really, there's no difference about sales tax and commission outside of you're just relabeling the parts. That's about it. So not very grandiose, I can guarantee that. Okay, even the word problems here are pretty much the same as the sales tax problems. So find the rate of the commission, same thing as we just did in the previous example with finding the sales tax rate. So not going to go over that too hard. It's like the same thing. So no use beating a dead horse. All right. More importantly here, is let's talk about the more practical side of things, which is like sales prices and discounts. So of course we all go shopping here. We're trying to search for the best deal. Okay, we want maybe a discount on an item. Okay, let's talk about sales prices and discounts. Okay, so let's talk about how it works here. In general, the sale price of an item here is equal to the original price minus the discount. So, you could save like, yeah, you say, hey, I save $5 on an item. So I just take that original amount and subtract it by the $5 that I'm saving on that item. And that's how much the sale price is worth. However, this is not the way we really want to look at it if we're given a certain percentage off on that particular item. So if we have to talk about a sale price here, and we actually look at the discount a little bit more carefully, I'm going to take the original price, but instead I'm going to replace the discount here. Discount is now the original price multiplied by the percent off in decimal. So if we want to talk about discount here and sale price, that's essentially how we figure that out. Is the original price minus the original price times the percent off in decimal. That's how we figure out what the discount is going to be here in this case. So I think that this formula here is a lot easier to look at because all we need to do here is just plug in the numbers here appropriately. We're going to get our final result that we're kind of looking for here. So let's look at this example. Whiting Oak Furniture Store has a home entertainment cabinet with an original price of $840 on sale at 15% off. Find the sale price of the cabinet. Well, if we just use the formula that we have up above, all we're going to do here is we're going to find the sale price here. That's equal to 840 minus 840 times, and then we have 15% here, which is equal to 0.15. as a decimal. Now again, I want you to notice here that 840 and 15% or times 0.15 is in parentheses, so you will need to do that first before you do the subtraction. Again, follow those order of operations. Parentheses always go first. So that's why I wrote it in parentheses, to make note that, yeah, you gotta follow order of operations still. So subtracting this discount here, we're gonna get $126 here. And if we subtract the 126, then the sale price here now becomes $714. So that's how much the sale price is going to be at the end of the day. $714 with a savings of $126. Okay, now that you have a pretty good template, all right, I'm going to have you try this first one down here. So it says an E-Z-Boy leather recliner originally priced at $950 is offered at a 42% discount. You want to find the discount amount and the sale price. All right, so let's take a minute here and let's have you guys give that one a try. Okay. Get 551. Okay. 399 for the yeah, I think 399 for the discount there. Okay. All right. Both very good answers. Yeah. Okay. Let's take a gander here. So Robert has the right idea for the discount amount, and I think 551 here is going to be our final result. But let's take a look just to be on the safe side here. So our sale price here is equal to 950. That's our original amount. Minus our original amount times 0.42. So given 950 minus 399, and that's correct. 399 is the discount amount. Okay. 399 is the discount. All right. And yeah, if we put that 2 and 2 together, our final price here is 551. All right, good. $551 for a leather recliner. Fine. All right, nice job, everybody. All right. All right, now the last thing I want to quickly talk about here is finding the percent increase, okay, or decrease here. Let's talk about that. So let's talk about the formula for this. How do we find the percent increase slash decrease? Well, what we're going to do here specifically is, in order to do that, we're going to take the new value, we'll subtract it by the old value, and we'll take that result and divide it by the old value. Okay. Also, as a reminder here for this, don't forget to change the decimal to a percentage at the end of the problem. Okay. So how does it work in a problem like this? Well, if you want to find percentage increase, decrease, we're just going to take, let's say in this case here, attendance at a county park climbed from 18,300 last month to 56,730 this month. Find the percentage increase. Okay, now all you have to do is label your old and new values. So your old value here is 18,300 and your new value here is 56,730. So all we're going to do is we're going to take 56,730. We'll subtract that from 18,300. And we'll divide that by 18,300 again. This should get us a decimal here in this case. Anybody tell me what do we get as a decimal here? Again, you have to subtract first here, by the way. So again, that's why I put parentheses there. So what do we get here as a decimal if we divide these? 2.1, that's correct. Now remember, we have to convert 2.1 is the decimal. What would 2.1 be as a percentage? Because that's kind of like that little extra step that we have to do. Oh my, 21%. Uh-oh. How do we convert decimals to percentages again, Samantha? Do we move it over one spot? That's what you did there. Try one more time. You're very close, though. At 210%, that's correct. Yeah. Again, you're very close there, Samantha. You just got to move it 1 and 2 spots, and then you're going to get 210. Yeah, so you just moved it 1. So it's so tempting to move 1, always 1 decimal place over. But remember, regardless of how ugly that number looks, you're going to move it 2 spots to the right here to convert from decimal to percentage. Or if we convert from percentage to decimal, you move 2 spots to the left. Everybody gets that mixed up. That's why I keep reminding you guys. It's the biggest trap in all of percentage problems is just that one point alone. Yeah, so sometimes it can be really tough. If it helps, divide by 100 or multiply by 100. If that makes it easier, then that makes it easier. So it just depends what you feel is easier. But yeah, it's the biggest trap in probably all of the percentage problems. That's why I constantly keep reminding you guys. Do I have all the notes for this class? Are you asking me that, Samantha? Oh, okay. Again, you can rewatch the videos if you like. So, all right. We may talk a little bit about percentage decrease here, but that's going to go into conjunction with what we're going to be doing here for chapter 9, which is talking about sign numbers. So we're going to look at positive and negative numbers here in chapter 9. As mentioned here before at the very beginning of class, we do want to discuss here. We're going to again talk about the test here. I'll be posting that up later this week, but that will be due next Sunday. All right, so again, uh, no pressure in finishing that obviously right away, but I'll be posting up an email and stuff. So it's it's a lot of those little things. Okay, guys, I want to thank you all for coming out here to the stream once again today. Um, all right, everyone, I would again, please enjoy your weekend. Okay, again, please enjoy your week. You know, I hope that you have a very wonderful Thanksgiving. I hope you get a chance to spend some time sitting down with your family and eating some good food. I know that obviously with the current circumstances as it is, that's um it's definitely a thing. Yeah, thank you very much. I hope everyone has a wonderful Thanksgiving. That's for sure. And remember guys, the big day could be December the 10th, okay? Big day could be December the 10th. Look out for December the 10th, everybody. That's the big day. It's not my birthday, obviously. My birthday was a couple months back. But no, more importantly, December the 10th could be the first time that a vaccine for COVID could be released to the general public. So, crossing my fingers here, and that could be the day the FDA could approve the first drug, the first vaccine for COVID-19 to end this entire crisis. So I'm hoping that it works. I'm hoping that it's effective across the board. We can get back to our normal lives. That would be poggers indeed. That deserves a pog right there for all the hardworking scientists worked over the past 9 months. We've been all stuck in these houses for the past 9 months, and I know everybody wants to get outside and do something. So December the 10th, everybody, look forward to that date. That may be the turning point of this whole crisis. I would really, really, I think a lot of people would appreciate that very much. So be on the lookout here. Things are looking positive. All right. Very positive. All right. There's a beginning, hopefully a beginning to the end. Yeah, look, I'm happy to give those updates because you spread the word. That's like I know it's been on the news, but some people just may not been aware. But that's they may approve the Pfizer vaccine on the 10th. That's when the FDA may go for emergency approval the same day they review the data. And then the following week after that, on the 17th, the Moderna vaccine as well, um, hopefully will be approved. So that's another one that's so from one week to the next, hopefully a pair of good news, and then hopefully after they start releasing the vaccine, it's going to be a slow rollout because certain people need the vaccine first before the whole general public does. But they said estimates kind of put it at probably by late next summer when you know pretty much most people should be vaccinated for COVID-19. So it's a two-stage vaccination, by the way. So it's not just one shot and you're done. You do have to get a second one. So, um, but I'll take two shots any day of the week over sitting at home for months on end. I think that just makes more sense. So, all right, guys, everyone, thank you very much again. Have a very happy Thanksgiving. Okay. Um, all right. And I will see you all here next Tuesday. Next Tuesday, we're going to talk again. You'll probably get an email from me here later this week regarding the test. But outside of that, and I'll put up a thing for 6/6 eventually. But outside of that, we should be good to go. Have a great weekend, everybody, and we will see you later. All right. Take care of yourselves, everybody. Have a good one, and we'll talk to you again soon. All right. See you, everybody.